radio's off. Just remember, and you need to see this, if you stick a regular screwdriver in this hole and you touch that, you're going to get a shock. Okay? That's just the residual on the capacitors after 15 seconds. Enough to cause that little spark. Okay, I just want to show you what high voltage looks like. Now if the radio was on and I did that, it would have blown the fuse and it would have been a big mark on the chassis, and it would have hurt the screwdriver maybe even. So a few issues that need to be taken care of with the TS-520. I have put up a 10 and 15 meter antenna. I wanted to be able to demonstrate the radio on the higher frequencies. We have some sunspots, and I found that I could not tune the 10 meter band properly. I was only able to put out about 20 watts on 10 meters. And I found that the tune control was all the way over to the right. So we need to address that problem. Also, there was some interest in neutralizing the TS-520. We're going to go through the complete neutralization procedure, and we're going to be using a scope and a radio receiver to do the neutralization instead of the proscribed RF VTVM they talk about in the manual, which nobody understands what that is today. So we're going to use an ordinary scope and an ordinary receiver to do the neutralization. So this is one more TS-520 tidbit in this video.
In New Hampshire, Mike, you heard Neil do that. Just give you a call twice and ask who hears me.
This is WU2D, Whiskey United 2 Delta in New Hampshire. Does anyone hear me?
5 and 2, Key West. 555 North Texas. 5 and 4 Northern North Dakota. 3 and 2 New Zealand. Here's Roger. 5 and 5 San Diego, coast to coast. 55 on my bicycle in California. 5 and 5 Santa Barbara.
I think somebody in New Zealand might have even heard this little 25 watts. WU2D, New Hampshire.
Yeah, New Zealand and Australia. Yeah, New Zealand, Australia, and Alaska is in there too as well. So Mike did a good job up there in New Hampshire.
Good.
So I now have a 10 meter and a 15 meter antenna up because I recognize that we've got sunspots now, and we're starting to get a little bit of propagation in those bands. So I put up a pair of rectangle antennas. Rectangles are full wave loops, and the rectangle shape allows it to match to 50 ohms more perfectly. A pure quad shape or a square matches more closely to 90 or 100 ohms, but a rectangle shape can be made to match almost perfectly to 50 ohms. So I'm using that antenna, and it works quite well. But I've noticed that I can get full power out here on 15, but on 10 meters, even though I have an excellent SWR, I'm only able to put out 20 or 30 watts. So let's investigate that. Again, here's 15 meters. If I go to CW mode and I transmit, you can see I'm putting out over 100 watts here on 15, and I have a pretty good SWR. At this frequency, it's around 1.3 to 1. The antenna is not perfect. It seems to be a little bit high in the band that it's a 1 to 1. When we go low in the band, it gets as high as about 1.5 to 1. So it's a little bit small, but that can be fixed pretty easily. Up on 10, I have an almost perfect match with the smaller rectangle. Let's go up to 10 now. Okay, up here on 10, I've just changed the frequency to the 10 meter band. And it's open. So let's try to tune on 10 meters. First, as usual, peak the drive. Set this up to 28. Put the loading in the middle. Go into the tune mode. And we are getting a little bit of power out. Let's peak that. It wants to be fully clockwise. Yeah, it's not putting out much power in tune. Let's try full power in CW. About 25 watts. That's it. 25 watts. Something wrong in the power amplifier cage. We need to remove some inductance on the highest band, 10 meters. So we are going to have to take the unit apart. We're going to have to go into the cage, and we're going to have to reduce the inductance on the highest band, 10 meters, see if we can get this power back. So it's time we did a little troubleshooting to find out why the power is so low here on 10 meters. So what has it been now? A week or two I've had the covers on this radio, and the covers are already back off. The symptom is it doesn't seem to want to put out much power on 10 meters, and the control is completely to the right. It won't go any further. At first I thought, you know, maybe it's this wire that's very close to the coil, the wire that goes to the fan. I should probably push that away from the coil. That's just good practice. By the way, we're in the cage. The cord is not connected. The radio is off. But even so, you should always check with a voltmeter to see if there's any high voltage. And even after you've done that, you should short with a screwdriver to ground this part right here, just to make sure everything is cold. You know, if there's no high voltage in there from the capacitors or something like that. So I see the problem already. If this is completely as little capacitance as possible, well, the capacitor's not opening all the way. So I think I see the problem. We've got to adjust the coupling nut so that the capacitor goes totally open when we get to 29.5. You know, sometime during the process that I was taking the panel on and off, or possibly even the former owner didn't get this set up right, and that's why we can't resonate up at 10 meters. Okay, there's 3 places where we can do this, but we'll try to do it here from the front. Okay, let's get this baby all the way to the right. There we go. We're starting to get there now. Want to make sure we got it all the way. There it is. Okay, that's better. Okay, now we're cooking. Can now get the full range on the capacitor. So I'm happy with that. So let's fire this up and see if we can now tune. Oh, I did want to move that wire away from the fan, so it's away from that coil. That's better. Okay. I will put the cage back on. Also, while we're here, I wanted to show you where the neutralization capacitor is. I wonder if you can see it. It's right there. That's a neutralization cap, and you have to put a plastic adjustment tool down through there to adjust the neutralization cap. Look what you're close to. You're close to the high voltage right on this tube cap. Talk about asking for trouble. Oh my God, that's a terrible setup. We will neutralize this radio. That's going to be part of this video. I definitely want to make sure that this radio is properly neutralized all the way up to 10 meters. Also, while I'm in here, there were some questions on why the TS-520's receiver is so quiet and pleasant. And one reason is the use of the dual gate MOSFETs up front in the front end of the receiver. They were pretty special at the time that these rigs were designed in the late 60s, early 70s. And the dual gate MOSFETs were also a little bit new to the game. So rather than keep having to change out MOSFETs on the production line, they decided that it would be safer to mount sockets for the MOSFETs. And there are indeed 3 sockets for the dual gate MOSFETs. This is not because the transistors blow up in use. This is purely a production situation where they were losing transistors on the line, and they wanted to be able to put the transistors in a safe manner, perhaps at the end of the line after all of the assembly was done. The last thing they would do is test the transistors and insert them in the sockets. So that's another place where you want to put the deoxit, or the contact cleaner, is in those sockets. Very unusual to see socketed transistors in the 70s. But in this case, we've got sockets for the dual gate MOSFETs, which are 4-lead devices. I'm hooked up to the antenna again. I think I want to put a dummy load on this, and we'll see if we can get a little more power than 25 watts out on 10 meters. Some folks might say, well, maybe it's the tubes are soft. Well, it's possible, but if it was putting out the full 100 watts on 15 meters, you would expect that it would at least put out 90 watts on 10. You know, the tubes aren't suddenly going to go bad. And the tune circuits are still fairly high Q. You saw that 10-meter coil. It looked pretty good to me. So let's see. We'll go into the tune mode. And what frequency are we on? We're at 28.5. That's a good place. Let's try 28.5. And I've got the drive in the middle. Let's put the plate up. So that looks good. Let's try tuning. Go into the ALC mode. Peak the driver. Right? Want to make sure we got some drive. And then the plate. Hey, that's better. I'm getting an actual increase. Okay, yeah, I've got enough drive. Okay, let's try CW. Ooh, that's better already. Okay, I'm up to 60. 70. Almost 90. Okay, that's long enough. You don't want to be keyed down that long, but yes, we are kissing 100. Okay? So that was the problem. That was the issue. The capacitor just was not in the right position, but we're happy on 10 meters now. So the first thing that I did is I moved that parasitic suppressor so that it's out of the way of the tuning tool. So there's a lot less chance of getting a shock sticking anything in there. Now if it touches that variable capacitor, which is also kind of in the way, that part of the variable capacitor theoretically is at ground, but should that disk capacitor, you can see, which is the main coupling capacitor, fail, high voltage would also be on that point. So there's no safety here like using an insulated tool. You have to use an insulated tool to do this adjustment. So let's talk about neutralizing the TS-520. Now obviously to neutralize the radio we do have to have the top cover off, which gives you access to the kind of strange angled port to get down into that neutralization cap. So they ask you to tune up on 21.3 megahertz. This is typical for neutralizing HF rigs. They usually don't want you to neutralize at the highest frequency, the 10 meter band, but they want you to neutralize at a high enough frequency that you're in the range where it really makes a big difference. And we find that when neutralization is not done properly, the rig will take off usually at the higher frequencies. It's usually going to be 20, 15, or 10 meters where the radio is unhappy. And when you change out finals, going from 6146s to, you know, different variants of 6146As and Bs. You almost always have to adjust the neutralization. The tubes don't have to be matched. You can use dissimilar tubes together, but if you do that, you need to always touch up the neutralization. What we are trying to do is to reduce the amount of positive feedback in the final amplifier back to the output of the driver stage. The final amplifier can turn into a power oscillator, and it can cause all kinds of interference. It can destroy the tubes. Sometimes you don't even know it's happening, and it can be a nasty situation. So you want to make sure that that feedback is reduced. And the way that neutralization circuits work is they're basically a bridge circuit. And when you null the bridge, the neutralization is complete. So we are nulling out the feedback using a bridge circuit. The front part of the bridge circuit is the grid of the final tube, and we use a technique called Breune, B-R-E-U-N-E, neutralization. There's a modest sized capacitor to ground, and then there's a small capacitance that comes back from the plate of the tube to the same bypass point on the bottom of the driver coil, and that is how we balance the bridge. So the first thing you want to do is tune up to make sure you're putting out full power on this frequency. So as usual, we go to the tune mode. We're in ALC, and we're looking for something in the drive, so we get the drive peaked up. Then we go to the IP, we look at the output, and we can see we basically peaked the tuning and the loading, and we have output. So now when we go to CW, we should have full output. And we do. We're over 100 watts. Now in CW, you have to be careful and keep this down to 200 milliamps, but we're okay for this test. Now, we're into a dummy load, and the next thing we're going to do is we're going to turn a switch off in the back that gets rid of the screen grid voltage on the tube, and that lowers the output power to a safe level for this test. So we're going to go to the back of the rig now. We're going to flick that slide switch down, and you'll see the power reduce. Through the switch down, we're going to go back to the tune, and now we're going to hit send, and look at how low the power is. The meter's not even moving. Okay? So we have reduced the power pretty radically. This will allow us to hook up an RF voltmeter, as they talk about in the manual. Forget about the RF voltmeter. We're not going to use an RF voltmeter. We are going to use either an oscilloscope or a receiver as our method to measure the output. And I have one of the best receivers in the shack. Yes, it's the Night Kit Star Roamer, performing duty with its wonderful S-meter to do the neutralization. We'll also be doing neutralization using the oscilloscope. These are things you might find in your shack rather than an RF voltmeter. So how do we get the RF? So what I've done is I have actually modified my dummy load. Let's take a look. Here's an ordinary dummy load. I've basically tacked on a resistor from the middle of the input connector to a 1K resistor to ground. So what have I built? I've built a 10-to-1 voltage divider. That 10-to-1 voltage divider is going to feed right into my scope or right into my receiver. I may have to use an attenuator for the receiver between this point, but at least it's a safe level that will not hurt the receiver or hurt the scope. So that is my test point, my pickup point. It's built right into the dummy load. Okay, you can see I've got the scope probe attached to the junction of the 10K and 1K resistor, and the ground of the scope probe is going to the chassis of the dummy load. So now you've got the message on using an insulated tool. One thing I suggest is with the radio off and everything high voltage discharged, that you squirt the neutralization cap with a little bit of deoxit or maybe some WD-40 or something, and then go in there with a regular screwdriver and wiggle it around a little bit to get it loose, okay, because that neutralization cap might not have been moved for a long time. Then once you do the real neutralization with the insulated tool, you'll find it'll be much easier to turn and get it adjusted. So anyway, we're now ready. We have the tool seated in the screw slot. That's something nice to do ahead of time to make sure you can turn it. And now we'll turn on the radio and using the scope, see if we can get a carrier up. See if we can get a carrier up on the scope that we will attempt to null. And everything is peaked up. Okay, I'm adjusting on the fly the tuning, loading, and drive controls, and it's all peaked up. Now we attempt to do the null. Now we're getting a nice null. Very nice. Okay, we have now nulled and neutralized the radio using the scope and the 10-to-1 reduction on the dummy load. This is the star roamer on a 15-meter loop antenna. It's working! Okay, so we know the star roamer is very sensitive on 15 meters. The S meter is even moving. That's what we're going to be using to null the bridge, is that S meter on the star roamer. Okay, let's go into transmit again with the switch down in the tune mode. The star roamer is detecting the signal. Okay, we have our S meter. Now we'll go to the neutralization cap. I'm tuning off. I think the star roamer did a better job than the scope. Don't you agree? Using the fantastic star roamer receiver with its sensitive S meter. Okay, the star roamer is approximately on frequency. Let's tune the S meter. Make sure we're on frequency. Okay, nice. That'll work. Now let's get on the neutralization capacitor and let's go for the null. Excellent. That worked perfectly. The star roamer was able to neutralize the TS-520 at 21.3 megahertz. I think it is time to start looking at the higher frequencies. We have sunspots. That means sometimes in the morning, sometimes in the afternoon, you're going to have some really great 10 and 15 meter activity, and of course the work bands will be hot as well. I should have put a BNC connector on my dummy load, right? So I don't have to have it open. That tap is a great idea. It's easy to add to this just by drilling in and putting in a BNC connector. I hope you're a little more comfortable with the TS-520 with this series. I've got a few more videos to go. Someone has asked for an alignment of the transceiver. Maybe that's where we should head next.